Today in Algebra 1, we're going to take a look at Lesson 27, Identifying Misleading Representations of Data. Our new concept today asks us to look at different displays of data and understand where the data is misskewed or is showing some type of misleading information that could point to some type of bias. When displaying data, components such as the scale or labels can make a graph misleading. Let's take a look. Example 1, identifying misleading line graphs. The line graph shows the number of members of a health club each month since it opened. Explain why this graph may be misleading. Well, if you look, in January there's a certain number of members, and it looks like from January to February to March to April to May to June, those numbers are increasing. Well, that might be misleading because you'll notice here there's this little broken scale at the very bottom. Because the scale does not start at 0, the membership appears to have increased much more than it actually did. Notice if you would have started at 0, then you're going to show this drastic increase, but because we started at 600, you're right here and it's showing this great overall increase from 600 to 900 members is an increase of quite a bit, but it's actually only 1/3 of what the actual capacity was, or a 30% increase rather than something looking like it's almost doubling during that time. Another characteristic that may create a misleading graph is the size of the increments in the scale. You go from 600 to 700 to 800 to 900, you've got 100 members as a certain point that you're kind of keeping track of on the scale. If that scale is too large, it looks like that line jumps up higher than it actually does when it's spread across that much time overall. So a broken scale, not starting at 0, can be misleading to show a different level of increase in a larger scale here in terms of the numbers and how high it goes up, or the increments of that scale are the second factor to how that line graph might be misleading. Take a look at example 2. Let's identify misleading bar graphs. A radio station conducted a survey of music preferences for listeners. The bar graph shows the results. Explain why the graph may be misleading. So think about what you listen to on the radio and think about what maybe other people you think listen to on the radio. What would be the most popular consensus? Well, here's an example of that survey. Looks like they listened or surveyed a large number of people, over 500 for each of these different groups. So 500, 1,000, 1,500, over 2,000 people were surveyed, and it looks like most of these are relatively even. Rock, pop, hip hop, and other are the different categories of the most popular musics to listen to. Now, how is this misleading? They all look like they're about the same. If you change the scale over here, do you think you could see a difference between these? Because rock and pop and hip hop and other look like they're all really, really close, but you can't tell which is actually higher than each other. The large increments of this scale make the data values appear to be closer than they actually are. If you looked at this more closely, if there was a scale between 500 and 600, or between 500 and 550, you could tell that, well, rock or pop or hip hop is that much more or that much less than the other. You could actually see that comparison. When you increase the scale, you can't see the difference between those values overall. Example number 3, things that are misleading in a circle graph. Circle graph shows the number of some type of sandwiches at a deli sells in one day. Explain why the graph may be misleading. So in this category, you've got a deli selling tuna sandwiches, turkey sandwiches, roast beef sandwiches, and ham sandwiches. Now, the title says sandwiches. Well, you and I both know that when we're referring to a circle graph, it's supposed to represent the total. Now, this says that it's showing some types of sandwiches. The title does not specify that these were the only sandwiches that the deli sold, and it may not represent all categories. A circle graph is supposed to represent the total or the whole. The deli may also have served a chicken salad or other type of sandwich, making this graph misleading, as in they left out information because they weren't really explicit in what they were saying or really clear what they were saying in the title itself. If any of that is ever left out, specifically with a circle graph, it can be really misleading to give these different categories a larger piece of that percentage if all of them are not included. Example 4, let's put this into application in terms of television prices. An electronics store created the graph to show the average selling price of a television each year. Explain why the graph is misleading. Okay, so what did we learn so far? We're supposed to look at the increments, how far those go up. We're supposed to look at the scale of where that starts. If it doesn't start at 0, then that can be a problem. If they have too big of increments, that can be a problem. Here it looks like those increments are too big to where it looks like those prices are going up just a little bit over time. Now, if you're somebody who's buying a television, you would want to see this. You'd want to say, well, if I bought a TV this year, next year the price is going to go up a little bit, but it's not going to be like it's going up or down to show that I've either spent too much money or not spent enough money and got a really good quality TV. So as a consumer, we want to see things that are true so that we're not spending our money in ridiculous ways. The large increments make the data values appear to be closer than they actually are. So actually the prices of the televisions are going up, but this looks like on this scale, on this graph, that, well, it's not much more expensive, even though that technology might be moving forward. Letter B. What conclusion might be made from the graph? What might the store have, why would the store create this graph? Well, if the store is trying to sell televisions, they don't want to make them seem like they're getting more and more expensive. They want to make it seem like you're still getting a good deal and not show you that over time. The graph seems to show that the prices have not increased much over the past 5 years. The store may want it to appear as though prices are not increasing significantly, when in reality they've actually gone up by almost 50%. Letter C. Make a graph of the sales data that is not misleading. So here's an example of that sales data that's not misleading. Now, it used a broken axis and it has smaller increments, and it shows, well, at one point the value was right around $630, $640, and now we're over $900 for that same type of television, or that average television price. Those values have gone up over those years. Now, in the early 2000s, this is when flat screen TVs and plasma TVs came out, and they were all the rage, so their prices were going up and up and up, but that technology increased. Actually, opposite is happening today, as televisions once got to this really peak price, are actually becoming cheaper and cheaper and cheaper as we're getting better at making that technology at a more affordable price. This would show consumers that, wow, TV prices are going up. Either I'm going to wait till they come back down and not buy them, which would be bad for the store, or I better get in early before the prices continue to go up, because they're going to be way too expensive down the road. So all of this is a way in which to kind of help protect you as a consumer, and to point out how people might use numbers as ways to mislead you in giving you that information. If we look at our lesson practice problems, in letter A, it says the graph at the right shows the number of miles a car traveled each year. Explain why the graph may be misleading. You'll notice here that the graph doesn't start at 0, so it's kind of hard to see the number of miles in comparison. And it also uses a scale of 1,000 for those overall miles driven each year, to show that the miles went up this year, down this year. It's kind of a misrepresentation, because guess what? Those miles should actually all be added together if you're adding the total miles on your vehicle. Letter B. The graph below shows baking temperatures of various foods. Explain why the graph may be misleading. A roast is at 300, a baked potato is at 425, cookies are at 415, and a cake is right over 300 and something. Doesn't look like there's enough data points in between these, or the increments that are clear enough for us to tell what those measurements are precisely. That's a big deal when you're cooking things, because you have to be really, really precise to make sure that you're following the recipe as it is created. That way you are successfully creating those things or cooking those things based on what's recommended. Letter C. The circle graph below shows the number of some kinds of dogs that were sold by the pet store. Explain why the graph may be misleading. Hopefully you caught it right there where it says some kinds of dogs, not the total. Anytime that it is a circle graph, we're looking at the total types of dogs, or all the different types of dogs, so that there isn't just a certain amount that are represented. It should represent all of them, or the entire total. In letter D, E, and F, we're going to use the graph that's shown here. A salesperson created the graph at the right to display the number of products he sold each month. Now think about this from the salesman's perspective. Why would he want to create this graph to show how much things he's selling? Letter D, explain why the graph may be misleading. It looks like, as you go from left to right, that every single month his sales are going up. Well, what does that tell his boss, his sales manager? Hey boss, look at me. I'm improving every single month. I'm getting better. Is that actually the case? If you took away the part of the graph that might be misleading. Notice there's a broken scale here, and those increments are relatively closer together. So the broken scale might show us a misrepresentation that he's actually increasing by a larger scale all the way throughout. What conclusion might be made as from the graph as to why the salesperson created this graph? This graph is meant to make him look better than maybe he actually is. Because if you look at some of these differences in their number, if they were spread out evenly, you wouldn't show this overall increase, as in he's doing a good job, but he's not increasing and going up as he should. If he shows this to his manager, maybe that means he's trying to get a promotion, or he's trying to say, hey, wow, look at how much I'm improving, when that's actually somewhat misleading. Hopefully that helps you with understanding misleading portions of graphs. One quick review. Misleading parts of a line graph: broken scale, increments are too large. Misleading part of a bar graph: the increments are too large, it doesn't allow you to distinguish between those different data points. In a circle graph, you need all parts to be represented so that the percentages are not skewed or are misleading. That should help you solve your practice problems. Go ahead and take care of those circled problems on your assignment page. God's blessings.